Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at sorting vectors in C++. So I've created this little test class here with an ID and a name, and I've given it a constructor to construct it with an ID and a name. I've also given it a print method so that we can see what's in it. And I've created a vector. I've added a bunch of these test objects, and I'm iterating through the vector and displaying it. So you see here I'm just getting the reference from the vector and calling the print method on it immediately, which we can do. The only downside here is there's a little bug in CDT that means it tells me the method print could not be resolved, but in fact it is resolving it. That's just a bug in CDT. So we can sort this vector two ways. Both of them involve using the sort function from the standard namespace. So we could type standard : sort, but since we're already using this namespace and there are no other sort methods available in our program, we can just write sort here. So to sort the vector, we just have to supply the iterator to the first element that we want to start sorting at, the iterator to the element where we want sorting to finish. And if we use this form, we're going to have to implement the less than operator in here so that this can actually work. So we can actually sort a range of a vector, so we can supply iterators to the start and end of the part of the vector that we want to sort. But it's more common to want to sort the whole vector, and so for that reason we're supplying test.begin and test.end. So we're saying sort the entire vector. So if I try to run this code, it's not going to work. We're going to get horrible errors. And if we look at the error a bit more carefully when it finally finishes, we look at the start here. We've got stuff about the less than operator not working, basically, although it's kind of hard to see that straight away from this error message. So we can just implement that. We can say bool operator less than, and we're going to supply a const test reference other. That's the one that we're comparing it with, and the entire method is const. It doesn't change test's instance variables. And we can say return, let's say return this name compared to other.name here. So that will work. If we run this now, when we sort the vector, we end up seeing that it's sorted now in order of name. It's sorted in alphabetical order. If we wanted to sort in order of ID, we just compare ID here. And if we want to sort, for example, first by name, and then if the names are the same, sort by ID, then we'd have to say here, if the names are equal, return comparison with ID, else return comparison with name. So we can check if those names are equal and return a comparison on ID instead, if we want to. There is another form of this sort function, because sometimes you've got classes that maybe you didn't even write yourself. You want to store those objects in a vector and you want to be able to compare them. So you could create a derived class perhaps and implement this operator, but an easier way to do it is to supply a comparison function, a comparator, to this sort method here. Let's comment this out temporarily. So we'll go to source and add block comment to add a multi-line comment there, comment the code out. We can create a function. It's going to return bool. We can call it whatever we like. Let's call it comp, and let's make it take two test objects to compare. So it's not going to change these objects, so we'll say they're const references, and I'll call this A, and a const reference to a test called B. So again, normally I don't like to use single letters for variable names, but sometimes like this, it's kind of traditional to do so. Here we're not going to do much in this actual function, and there's no real meaning to these except they're two test objects that we want to compare. So I'll just call them A and B in this case. And then we can say return, let's say we want to compare on name, we can say return a.name is less than b.name. So we take the first argument and return whether it's less than the second one or not. And we can supply that function now to sort. So you might wonder what this is, and the answer is it's a function pointer. We're just supplying a name to the function. It's actually what we call a function pointer, and we'll look at function pointers a bit more later in this tutorial. This isn't going to work yet. If we try to actually build it, what we get is we get some errors, and it tells us that name is a private member of test. So of course we haven't put private here explicitly, but by default the instance variables in a class are private, whereas in a struct they'd be public. So we don't want to make these public. We'd like this function to be able to access private members, and we can do that by putting the function prototype into the class like this, and by using the keyword friend. And what that does is it says, okay, if you see this function, which of course at this point, as we scan down, at this point it hasn't been seen yet, but we're saying that when you find a function with this prototype, we're going to make it a friend, meaning it's allowed to access our private members. And now it works. So if we build this and run it now, let's build the project and run this, then we can see now the vector is sorted in alphabetical order: Mike, Raj, Sue and Vicky. And we could sort just a range in alphabetical order. For example, instead of putting tests.end here, we could say tests.begin +2. And if we run this now, we're going to sort the first two elements in alphabetical order. We've got Mike and Sue, but these two are not sorted. If we want to sort the first three, we could put test.begin +3. So now we've got Mike, Raj, Sue, and Vicky happens to be in the right place anyway. Let's just move her to earlier in the vector to demonstrate this. And so if I run this now, we see that we've got Raj just at the end, unsorted, and the first three are now in the right position alphabetically, but usually you want to sort the whole thing. So it's not efficient to sort a vector. Obviously the sorting algorithm is going to be implemented as efficiently as possible, but it's going to take time to sort a vector. And for that reason, if you've got a situation where you want to sort the vector after every insertion, then you don't want a vector, you want a set or something else that's going to keep it automatically sorted. But if you just need to do a sort occasionally on your vector, for example when you've finished adding all the elements, then this might be a good option. So I'm going to leave it there for this tutorial, and probably I'm not going to add any more tutorials on STL, but I just want to mention that there's at least one more STL class that we haven't touched on. It's called deque, and that's worth exploring. So it's an acronym of double-ended Q, which is wireless strange spelling, but it's pronounced deque. And my internet's being a bit slow here, but if you look at this, it's actually very, very similar to a vector. You can iterate through it. The difference is you can add members to the beginning as well as to the end. So it's not going to be as efficient as a vector, but you can only add elements to the end of a vector. And here it's a double-ended queue. You can add items to the end and the beginning. So there's not only a push back, which adds to the end of the vector, there's also a push front. If we just check down here, there we go, push front. And we've got pop back and pop front. So I'm going to let you investigate that yourself, because we've already seen all the techniques basically that we would use with this, and it's really, really well worth getting a bit familiar with the API docs. Google for STL deque and with this strange spelling, and see if you can figure out how to use it using the API doc. And if you've absorbed everything we've seen so far, then you won't have any problems with it, because we've really seen everything that you can use with this structure, so I'm not going to repeat it here. Of course, it's also worth practicing sorting your own vectors. So I'd say declare a class, make something up, try making something up other than what I've shown you here, some sort of class that contains some sorts of fields, and then try both ways of sorting, both with implementing the less than operator, and also with passing it a function pointer to sort it. So try those out, and you'll get a bit of practice with friend functions, as well as implementing the less than operator as well, and sorting in general. So it's a really good thing to practice and have a look at deque. Okay, so that's it for this tutorial. Until next time, happy coding.